And we're off.
Okay, hi everyone. My name is Azriel. I work at MIOB, and I am they call me a DevOps engineer, but I do anything. So today's talk, we are going to be looking at a library I've been working on for 2 weeks, but I promise you it's good. It's called choochoo. It's meant to help with writing robust automation tools. So I created this library because over the past number of places I've worked, there's always the same problems when you deploy software and do configuration management. And so the library itself is not specifically tuned for deployment automation, but it's going to be really helpful in that area. But you can still apply the concepts you learn here to other areas of software. Yeah. Cool. So let's begin. So in deployment, in software deployment, usually we have some sort of workflow like this. So upload an app. Actually, can everyone read this? Or is it a bit too small? Okay, let's make it big. Big. All right, and let's hide that thing. All right, so usually we'd upload some binary that we've built. We created some database for the app. We download the app onto web server. We link the app to the database, start it up, allocate some domain, attach it to the server or some sort of front end for it, and then notify somewhere of completion. So you can say, hey, this service is now up and running. So that's a very typical workflow. Now, unfortunately, things do break, and so we will be exploring actually a few software dimensions, as I call them, where when we build tools, we tend to try to make them resilient, but we don't always make them resilient in a way that's user-friendly to the end user. And so when I created this library, I kind of separated these dimensions out into different distinct things, such that we can reason about them individually. And we'll see how choochoo helps us raise our maturity in each of these dimensions. So dimensions, well, in the physical world, okay, dimension might be an object's size, mass, temperature, color. So they can be independent of each other, but you can also deduce maybe one dimension from another. Like maybe if you increase size, the mass will also increase. So they can be related to each other. So for software dimensions, which I just coined this when I was writing this, we'll look at 6 today: path handling, state visibility, understandability, recoverability, performance, and psychology, which is actually more of a human thing. Yeah, but it does come through in software a little bit. So path handling. So how exhaustive code path coverage is and how each path is handled. So we'll open this in a new tab. So when we write code, each step that we execute tends to have multiple ways it can end. But languages tend to be favored in, well, they tend to drive you towards it's going to succeed with one return value, or it's going to fail. And you might have these in exceptions. Rust changes this a little bit by having some types, so you can have a result with OK or error, and then each of those two variants are type parameterized, so you can succeed in different ways. So it can be, OK, I succeeded because, so let's say for uploading an app, we might succeed by we've uploaded the thing successfully, or we might succeed by the thing was already uploaded, so I didn't have to do any work. For failure modes, there's multiple, especially if you're going across a network connection, whether the end happy to receive you, whether the end exists at all, etc., etc. So maturity levels for tooling tend to be, well, kind of these three: happy path only. So you kind of, if you're writing a hacked up version of a maybe proof of concept for deployment automation, you might just curl post this here to there. It worked versus it didn't. So this is quite common in languages where you'd go, I'll try upload it somewhere, catch all exceptions, treat them the same, or maybe just bubble up the exceptions. And it failed or it worked. So 99% complete path handling is when we treat each execution path uniquely. So by that I mean, when it succeeds in one way, you treat it this way. If it succeeds in a different way, you treat it another way, and so on and so forth for each of the failure variants. And 99% complete because usually you cannot encode stuff like the power went out into your code, and your code can't say, oh, the power went out, I'm going to do this, because the code doesn't exist anymore. Right, so there's different maturity levels. And so for choochoo, the library, so it's really up to implementers of tooling to encode each path handling properly. But as a library, it needs to, so what choochoo does is, given implementers have specific workflows, but want to take advantage of what choochoo can provide, which you will see soon, choochoo needs to place some constraints on constraints or requirements on the code that's fed into it. So if we want to allow people to handle, say, all errors uniquely, they need to provide us their error type. So for that, choochoo type parameterizes the error type. For constraints or requirements, because choochoo needs to treat the error in a certain way, or use the error in a certain way to present it in a nice way to the user, we place a requirement like a trait bound. I have one called as diagnostic, which will say, you can give me your error type, but it must be able to be turned into a code span reporting diagnostic. So code span reporting is a crate which, if you've written Rust and you've seen Rust compiler error messages, code span reporting creates those error messages for you. Yeah, we'll actually see a live demo, so it will be clearer when you actually see that. Okay. And source error, this thing here, is kind of a layer between just an error type and code span reporting. It makes sure you have a strongly typed error code rather than, so code span reporting takes in strings for your error codes. Source error is a admittedly immature library which I've written to just model your errors with strong types. Okay, so we'll do a live demo. So this live demo will actually be this full flow, and we'll see how we handle different error cases as well as the success case. All right, so I've done that. I'm going to copy that one. So here's my demo, which I just built a little bit ago. So if I run it, first it fails, saying failed to open app.zip. So I'm trying to upload an app to an artifact server, which the web server will download from. And you can see that I've got a nice error codes there. You've got the path to where the application was meant to exist, and it gives you a hint, just like Rust errors, which is really nice. So if I run this, come on, and it's at the bottom. So it doesn't exist, but we can create it. So this is a little command which I use to create a zip file. It is 515K in size, quite small. We can make a bigger one later. So if I try to upload it now, it says, all right, the file, which is 515 Ks, it could not connect to the artifact server. So here it tells you the server address, port, and it gives you a hint. Here's a command to run. So it's quite nice. You don't have to go and dig for that information for you. So the path handling is still up to the implementers of the automated tooling, but presenting that in a understandable way to the end user is something that choochoo will help you do, because it places those requirements on the implementers. You need to implement this trait for your error types. So let's do that. So we start the server and we'll run it. And you can see that it runs. So the first and third one, A and C, upload and download app. Yeah, so those are properly implemented. B and the rest of them, those are implemented with sleep. So it just that task. But we do want to at least have an indication of there is a dependency. So you can see that we do handle different cases. I think there's a list of scenarios I wanted to run through. So happy path, okay, so stop server before downloading. All right, so I will show you one more interesting failure. I have this thing which clears the state. So what we're going to do is we're going to upload the app. We're going to pause the app before the download and remove the app from the server. Right. So that's it's an unusual thing to happen, but when you do deployment automation, you get really unusual things. So we'll do that again. So I paused it. So it just Ctrl Z gets to background the task and pause. We're going to not that one. I think that's the one, yeah. So if we foreground it, okay, so you can see upload app and create database, those succeeded, but the download failed. And the download failed with another error, error code. We tried to hit this URL, and the hints you get are ensure the file exists on the server, and here's a message from the server when we try to download it. So all of that information is presented to you, the end user, without having to go and dig. You don't have to simulate that request and do your own posts and stuff like that. So that's really, really helpful when you have a deployment automation tool and you scale it out to all your staff, and you get all your staff having different errors. I mean, sometimes the same error, and they all come to the same team, hey, it's not working, and team has to investigate. That's a cost, because you have to investigate each one. Whereas if you can encode that information into the tool, for the tool to do that discovery for you, and hopefully the error message is understandable to the end user, then you've already saved your bottleneck team a lot of time. Cool. So let's just reset this. Reset. Yeah, sure, you can reset. I think we don't have to run it again. All right. So that's code path handling. Most of the work is still on the application or the tool implementers, but for choochoo, the library needs to be able to allow them to pass that information through the API. Our next thing is state visibility. So what state is the tool in now, and kind of progress tracking. So is enough information captured by your deployment tool, and is it presented in a way that the user can see the state of the deployment, or any workflow really? Okay, so maturity levels, it's running versus it's not. Yeah, these all expand, but we don't need to really see detail today. The zero visibility tool is, I've started a long-running process, and I have no output. Yeah, so that's sometimes it's not because the tool has no output, but sometimes it's because the user has no access to see those outputs. Maybe it's on the server somewhere, or maybe it's just we've blocked them from the progress page because that access gives them more access than they should have, right? So there's those implications. So that's more of a did you get your roles correct kind of thing. The next level of maturity is the imperative tool. So imperative tools, when you run your deployment, it moves forward and it prints as it goes along. And what that means is you can see the completed steps, but not necessarily the remaining steps. So you don't know where the end is. So say you've got 100 steps, but you're on step 5. You don't know whether 100 is the end or whether 6 is the end. Many automation tools are like this. Yeah, so the next level up, which is actually a lot more helpful to the user, is the planner. It will tell you the whole process, overall process, and it will tell you you are at this step of the process, so they know the end point. So I mean, it's nicer to know I'm at 99% rather than I'm at unknown step. Yeah. So progress bars are like a thing, right? So you have an end to the progress bar, and hopefully you know that end, as in you don't want to tell the user you've got 10 steps. It's like 6 of 10, 7 of 10, 8 of 11, 9 of like 20. It's like, why? Yeah, so progress bars, the end should be an end. If it's unknown, then let them know it's unknown. Yeah. Okay, so API implications. So for choochoo, this means we need to know some level of overall execution steps. So if you need to discover more steps at runtime, you can do that, but still have your overall plan. And you can update maybe sub-steps in your UI in smaller levels of detail. Elapsed duration, so how long you spent on the current steps, is essential because you don't want someone to kick off a process. It takes, and they leave the computer running. It takes maybe 10 hours longer than it should, and they don't know how long it's taken because they left their computer. Yeah. Yeah. So that's essential, and accurate duration, or estimated time of completion is like nice, but sometimes it's quite hard to provide that. So what choochoo does is, so all tasks are listed. We'll see this, and yeah, each task has a progress limit, and you've got colors for failure, success, or in progress. So if we look at the actual thing, we'll run this. So I'll pause it again. So the thing that's finished is green. The thing that's in progress is light blue. And things that fail, let's just make it fail again. Whoa. Foreground. Right. Yeah. Things that fail will be red. You can't really see the diff. Oh, you can actually. So the thing that failed here, the thing that actually failed, is brighter red than this thing, which failed because of a parent failure. So that means the user can tell at a glance what succeeded, what failed because there's an error there, and these things didn't even run, but they are considered failures because they depend on something which did not work. So, and you can see there's dynamically changed end limits. So if I change the file size, which I will do by making it bigger and rerunning the program. This may or may not work because the server has a limit and I didn't use the bigger limit. Alright, let's go. Oh, it worked. So you can see the file size changed from 500 something kilobytes to 5 megs. And so we had to re-upload that and re-download that. Oh, I'll download it because it wasn't downloaded the first time. Okay, so let's see. State reliability. Oh, okay. So next is understanding, which is really closely. Whoa, I don't see that. Not yet. All right. Understandability is really closely linked to state visibility. So state visibility just means you can see the progress. It doesn't mean it's understandable. So there's this thing where you've got text everywhere, right? Like Buzz Lightyear. So if you've got like 200 megs of logs per minute, like just scrolling past the human, they can't understand what's going on. It's too fast. So what's better is reduce the amount of information you provide to the person, because we have limits. We should have limits, I think. So we show useful information and hide unnecessary information. So what that means is maybe for a current step, showing more information is useful because I want to know what's going on behind the scenes. But when that step succeeds, fold that information away, hide it, because it's worked. Now I know, even though I wanted to know the sub-step information, hiding it away after it succeeded means I know it's done what I needed. I just was interested in that bit at the time. So after it's passed, I'm not that interested in that anymore. Cool. So right now, choochoo only shows you progress bars. It doesn't let you do sub-step information. That's because I haven't had much time to play with the API. But you can see that you can actually see a hint of what's coming next. But you can see what the endpoint is. You can understand what's finished by the green bars. You can understand what's in progress by the blue bars. And at a glance, you can see, well, pretty much everything. And a nice thing you can do is highlight important information. So the task steps are nice to have. The task IDs may not be that important until something goes wrong, but you can dim those while it's running. And if those are actually important, then people will actually look for that dimmed information. This is how we do our syntax highlighting in source code, right? The comments are just dimmed because you want to read them once for docs, but usually you're looking at the code rather than the docs all the time. Yeah. Though that said, I think it might be interesting to say, if we're writing docs, use this sort of highlighting so the docs are highlighted brighter, and then dim them if you can like toggle that. But haven't seen any editors highlight things like that before. Cool. So yeah, and example errors. You've seen one for real. Yeah. Oh yeah, and for errors, you don't give users stack traces, because stack traces are for devs, and usually stack traces are for computers rather than for humans. Humans read the stack traces to figure out what the computer is doing, whereas if you have a stack trace, that means you have a call hierarchy, and if you have a call hierarchy, then if you fail, the thing that called you should know about the failure and handle it, and try to present that in a way that's useful to the end user, rather than just let it go and then the stack trace is just printed to the user. Okay, so implications for making understandable UI. So for choochoo, we just present the mechanism to specify the end limit for our progress bar. We collect information and we present it in useful way. So while the app is running, we will have your real-time progress bar. When it fails, if it fails, then we'll provide you just the error, just enough information in the error to figure out why it failed. And we try not to show progress through logging. So the library used for progress bars is indicative. The color changing is handled by choochoo. And the limits, the implementers of the deployment tooling would have to tell us what the limits are. And it can be dynamically updated, but again, for good user experience, you don't want to extend the limit every time. And code span reporting is the library used to render those errors. So one more thing. So indicative, the progress bar library, it shows you it calculates the elapsed time, from a start time, and it also estimates the time remaining from the percentage of what the end limit is, what your progress step is, and how long it took. So it can kind of extrapolate how long it needs to do the rest. So choochoo doesn't do that. But we just lean on the smarts of others. Okay, recoverability and repeatability. Can execution of your automation resume from halfway? So let's say the workflow steps got up to like the 7th step, and then it failed. All right, what happens next? Depending on the maturity of the deployment tooling, well, the lowest level is not you just start again. The lowest level is you have to clean up, and it needs manual human intervention to clean up the things that got created during the first failed run, and then you restart from scratch. The second level is you can restart from scratch because there is automated support for cleaning up the resources or things that got created. So for example, if you deploy 10 servers and something else like the database failed, there is automation to terminate those 10 servers. Otherwise, it's just going to be a cost that's lying around. And the third level, reuse and recycle. Oh, wait. Before we get to that third level, restart from scratch has a variant where you don't want to automatically clean when it fails just yet. You might want the failed environment to stick around for investigation for why it failed, and then you clean it up after you've done your investigation. Okay, so the third level is reuse and recycle. So if we've done 7 steps or 6 steps successfully, and it failed on the 7th step, we should, in theory, be able to reuse those resources created from the first 6 steps, unless the issue was in an earlier step which falsely succeeded. So, and that means if the issue was really with the 7th step, I should be able to rerun or restart the process on the 7th step, and I don't have to wait that duration that the first 6 steps took. So, like if you fail your download at 99%, do you restart at 99% and download just at 1%, or do you restart from 0, right? So what choochoo does is, if it's already done, we don't do it again. If it's done before, but needs tweaking, we will, so this is still up to implementers of the tool. You need to be able to look at a thing that you created in the past, tweak it. So for example, tweak the configuration value of a server which was created, and then you need to propagate that change to your dependencies. So example is re-download a file if it changed, restart the web application if configuration changed. So yeah, we've mentioned that. You can see that in the live demo soon. So API implications. So what choochoo does as a requirement for implementers is we have a check function, optionally provided by implementers, but should, where you check whether the thing is in the desired state. This is actually a learning from Puppet. So if it's already in the desired state, don't do the work. But if it's not in the desired state, then there's a do it function, which we call a visit function. And if the check says it's not in the desired state, we need to visit it, then the visit will be called. And if the visit is called, after the visit is called, choochoo will go, all right, it should be in the desired state, and so I will reuse that same check function and call it again after that, which means if it returns it's in the right state, that's a good thing. But if it returns it still needs to be visited, which means your do it function didn't do it, or there is a bug, then we surface that to the user. So this is another constraint we place on implementers. So your error type must implement from these choochoo errors. Yeah, so right now there's only one choochoo error, but it will probably grow. Okay, so live demo. Da-da-da. All right, actually, you've seen we've done stuff. If we run it again, it finishes pretty much instantly. So 44 milliseconds. Previously, it took 5.7 seconds, and that's with this other wait previously done as well. So that means if someone runs the command again, which is a very human thing to do, if it doesn't work, try again. And when we're not tuned to figure out why it did not work, we're like, it didn't work, let me try again, because that's the approach we are psychologically tuned to do in life in other areas, right? You fall down, you get up, and you go again. But computers are not like that. So computers, they're not usually designed like that. So if you design a tool where I'm going to do stuff imperatively, so do steps A, B, C, D, E, you try again, you're going to start at step A again. So if your logic is not written to tolerate previous executions of A, B, C, D, E, then it's not going to work well. So choochoo will place this constraint or requirement on implementers such that we try to make sure the implementation of the software is fitting for how users use your software. Okay, so I can show you if let's say I pretend that one needs to be done again. rm-rf. Let's just do this, and we run it again. It should only do the one that's needed doing. Okay. Do I miss anything? I guess we can do this. So you've kind of seen it before. If I update the zip file size, so right now it was 5.6 megs. If I run it again, it's going to be the smaller version because I just changed it. So upload had to rerun, the download had to rerun as well. Okay. How many slides do we have left? Should we pause? And yeah, let's go. Does anyone have any questions?
Just before you show, some being done on all the later steps, it was already done, so not a problem. I'm assuming you've got something to say like this depends on the one button, so if that one hasn't run, you can't assume this one.
Correct. So this is something I still need to encode into choochoo, where if a parent step has changed, the check function for the subsequent step needs to know about whether the parent step changed. And I haven't designed that part yet, because the parent step is a thing you should inspect to see whether the next step should run. Because, for example, if your configuration file has changed, so parent step might be change this configuration file, the next step might be start the service, and the check function might be the service is running. It is running, but it didn't pick up the changes from the config file. So you need to have something which goes, if the config file was changed by my parent step, then I need to restart the service even though it is already running. Actually, right. Okay. Yeah.
I was just curious if you had the possibility of theming it for people who might be really, really colorblind. So
Yeah. So the theming was done on Friday night when I was quite tired. Alright, yeah. So most of this was actually implemented on Friday, Saturday.
do they have blue, orange, and red, green?
Yeah, because having like the the dots versus the like fully shaded thing, it might be a thing as well. Yeah.
In this section of recoverability and repeatability, I was interested to hear you say that sometimes you'd want to roll back and sometimes you would want to keep the state there. I guess how easy is that? Is that configurable so that there's logic? Can the user put the logic in there to say, in this condition roll back, in this condition keep it there, so that you can,
Yeah, that's something I should encode into the API, right? I haven't actually done that. So that's actually something which does. So when you do something, usually you want to know what happened or what the state of the system is in before you do your stuff, and then if you got halfway, how far do you roll back, right? What's your stable state? I have not got anything intuitive for that yet. Yeah, but that's definitely something important to have.
maybe because you have the concept of a parent task and child task, that's where you could put it.
Yeah, I guess you could have child your child task or your subsequent task actually depends on your outcome. Yeah. So the current task, if the current task failed, do you insert this new rollback task kind of thing, which means it changes the overall execution plan. Yeah. So I have not thought about that, how to do that properly. But certainly important. And so.
Yeah. So you mentioned you used a crate, I suppose, for your progress bar. But what about the rest of the user interface? Is there like any kind of command line-y crates you use for rendering the UI?
So Indicative, which was originally written by Mitsuhiko, he also wrote something called Console, which lets you style text. But there are many NC styling crates out there, like NC is one, Yancy is another one. That said, so Indicative can render to a different backend, so you don't have to render to standard out, for example. You can render it to some location memory, and you might want to implement a different renderer which says, oh, I'm going to render to HTML and stuff. Or maybe just render the progress, not render the progress, but the progress bar itself contains the state, so you might want to save the state in the progress bar, but not actually use it as rendering, and you transfer that state across like a web REST interface or something like that. So you can render your progress and maybe a web page, and you're using REST calls to update yourself.
Mm-hmm.
Yeah. Other libraries, I don't think I've got many. Yeah. Right now I try to keep dependency count low. I'm gonna keep that alive. All right. So I have not done the separation between core execution logic and rendering. So right now it's quite interleaved because I mashed them together quite quickly. But ideally we should have an executable core thing that the library provides, where you can plug in your logic and run your workflow resiliently, and you can choose how to render that, how to present that. It doesn't even have to be to a human. Yeah, it can be to maybe some monitoring system.
Yeah, so if you do it to a text file or something like that, like that progress bar won't work
Correct.
very well.
Correct.
Yeah.
Well, you have to progress bar with like all of the steps, like building out.
Yeah. So
Right,
that's a more mature version of what you have at the moment.
is the expectation that your users are writing Rust code, or do you have a declarative language that you're feeding into choochoo?
Oh yes, I should repeat the question really. So is there a requirement to write Rust code? Right now, yes, because these are all encoded in just Rust traits. But the same design, like this is how you should, let's say Java or C#, here's an interface where the implementers must provide these method implementations. And that same design can be ported to different languages. The hard part is, I haven't worked with other languages where you've got exhaustive pattern matching to some types. So like say Java or C#, you've got your switch case, but I haven't actually spent much time in this, but if you do have a closed set of variants of how your function can end and data associated with those variants, can the language have an exhaustive match and not give you a superfluous, you miss out the default case kind of thing, yeah. So, yeah.
It's great to see shop economy, the proper norm.
Yeah, there is an open ticket which I am tracking for C#. Yeah, because I tried to do that at work. Okay, good night. Cool. Let's go on. Okay, so performance and efficiency. So there's a hint earlier on, but how well is task execution scheduled, and how well do you spend your time and resources? How well are they used? Like how well are they shared between tasks? Because if two things want something mutably, then well, you're gonna have either a race condition or some sort of lock, and you. I'll leave something out. Yeah. Okay. I might bring it back in soon. So, for this workflow, go big to flip. All right. For this workflow, the actual logical dependencies are kind of like this. So you upload the app. Well, you can create the database first, but this is how I did the graph. So you upload the app, then you can create the database and download the app onto the web server at the same time. You can link app to DB and run are actually swapped. All right, so D and E should be swapped, I think. Yeah, so D and E should really be swapped. Then allocating a domain can happen independently. You can do that even though the web server doesn't exist. Attach domain when your web server is running, and then notify of completion. All right, so if we can define this dependency graph like on paper, then we should be able to encode it into the tool to run those tasks as they as you can see here. So maturity levels for concurrent execution. See this. Well, the simplest form is just sequential. You just run everything one by one, and it's actually very simple for troubleshooting. Very usually already good enough. But so if you don't have extra threads, then you would have no threading problems. I think I haven't tried getting single-threaded problems, but I had something to say, but things are stuck in my mind. Okay, if it comes back, I'll mention it. All right, so the next level up is you have coarse parallelism. So you make a thread per task. When it finishes, it just ends. And more threads means more speed, right? Not true if you have not designed for it. So if you have one thread per task, it's like having one person allocated to each task. If your task breakdown is not good, then that one person is just going to be doing nothing, right? So there is more granular concurrency. So this is what we, in Rust you call it async await. Some other languages use the same terms for different concepts, but I think C# uses it for the same concept. JavaScript, also same concept, but a bit different in how it runs. So if you have a person and they're doing a task and they need to wait for something to happen, you can get the person to do something else. So that's task hopping. So if you have async and await capability in your language, then you can say, all right, when the CPU is going to wait for I/O, then await on the I/O, await on that operation. But while you're waiting for I/O to complete, do something else. So this is using the same thread to do different stuff. So I guess cross parallelism is something which most people probably learned in university. I only came across async await when I played with Rust, really. So I'm not sure if it's actually been around for much longer than that. But I did read this thing where you need to mess with the stack registers, which is very low level to get async await working for any language. Yeah.
I came into C# in 2010.
Ah.
I don't know, my supervisor's been teaching us a few years, but I think probably it didn't really get taken up until the last 5 or 6 years.
Okay, yeah. And the C# model is the one which many languages have adopted, so they got it right. Yeah, so it's really good. Okay, so for choochoo to support getting granular concurrency into a deployment tool, then, well, we need to support async await. So we use asynchronous functions to operate concurrently. You can use multiple threads for parallelism. So that's depending on your runtime. You can just tell it, runtime, give me how many threads. So shared data across tasks must be behind appropriate. I put down read-write locks, but it's just really, you need to manage it well. And read-write locks may not be the right thing for each piece of data. Yeah. For example, if your task needs mutable access to 2 things, you shouldn't borrow one, get the write lock, and try to borrow the other, because someone else might, in between there, grab the write lock for the second thing, and wait for your first thing, which you've got the lock on. So you've got your deadlock there. So this is the thing which I didn't want to say earlier, but I shall say it now. You can, in Rust, have runtime mutable exclusive block management. So you know how in Rust normally if you try to have 2 mutable references to something, it will say no, the compiler will say no. So you can you can convince Rust that at runtime I'll manage this thing. So I will treat it as immutable when I write the code, but the code will go, I'll try and borrow this thing mutably. And at runtime, so at compile time, the try and borrow that thing mutably will be an immutable call. And at runtime, if 2 things call that same method, the first one will get it, the second one will get a none, or a panic if you just made a panic on 2 calls to that. So that means if you want to share something across multiple threads, you need to have an immutable interface to satisfy the Rust compiler, but have a runtime-based mutable access. And shred, which is a library which I looked at the code for this, is they've got an any map, which is a map of, a hash map of type ID to any type of object. So you can actually in Rust have different object values of different types, different classes, or different structs stored in the same map, which is quite interesting. And what it does for tracking mutable or immutable access is when you try to borrow something from the map, it will at runtime check how many references have I got to this thing, and if it's I think it uses a U8 or it might be U32. But if it's 0, then no one's got a reference to it. if it's 1 to max minus 1, that means it's all read accesses. You've got that number of read accesses to that object. But if it's the max value, we treat that as a write access. So if you're on the max value and you try to increment that, you can detect it in Rust at compile time. So it'll know someone is trying to access this, even though there is mutable access to it already. That probably goes over everyone's head because it took me ages to actually understand the code for that. But pretty much you have a map which tracks your immutable access, and you use that to share between all the tasks. So right now, choochoo has this map which we give to each task, but it does not have good support for blocking implementers from creating deadlocks. Yeah, so I'm still working on the design for that, because Shred's design is very clever actually, but I want it to be even more granular, and yeah, haven't spent enough time to make that work. All right. So yeah, just as an additional note, for return types for the functions which choochoo requires implementers to implement, we use pin box dying future. So it's an async task future. Pin means if a thread starts a task, then or creates a task, I think, then it must be that thread to progress a task. You can't get a different thread to work on it. And choochoo also uses Tokyo as the async executor. Okay, so that's a lot of talk. Let's look at the demo. So let's just clean up and then restart. Whoa, and restart what we did here. But what we can do is we can go concurrent. So let's do it sequential. And you can see it'll take about 6 and a bit seconds. And when that's done, so it took 6.8 seconds. If we run it concurrently, it will take, so it did a few things at the same time. We can do that again. It took 5.6 seconds. So just to see how much savings that is, that's I think it's 6.8 over 5.6. 5. Yeah. All right. So about 20% faster. And well, just to pause it when it's halfway through, you can see that upload app or another app I finished, but allocate domain is running while the other stuff is running, like create database. Yeah. So that's our concurrent execution. The dependencies are specified by the implementer. So I guess I can bring up the code. Alright, so if it's sequential, then we just depend on each thing. A goes to B, B goes to C. So it's a forward graph. Zoom in, yeah, of course. Yeah, so essentially these ones are A goes to B, B goes to C, C goes to D, and so on and so forth to the end. This one we've got, if you trust me, it's the graph that you saw earlier. Yep. So it's essentially this graph. Yep. Okay. So I think this is our last dimension. Psychology. Did the user request what they intended? So does your software, does your tool understand the intent of the user, even though you receive the command to do X? So this is really, can the developer predict the end user's behavior while they are writing the code? So, and this doesn't exist in choochoo, I'll just say that earlier. So choochoo deploy server count 100, which essentially is make me 100 servers. So we can naively do as the user says every time, because we are being correct like the user says deploy 100 servers, I should deploy 100 servers, right? But what did it really mean? Does it mean, do we guess the desired state? There's already 10 servers where they ask us to deploy, so we'll deploy 90 more because we are clever. We ensure that the 100 servers are deployed. Or do we really protect from extreme values? So this is just an example of how it could look like. Warn the user, this is what you gave us, and so give them some information. This can incur high costs, and you need to if you really mean this next time, you can give us this flag so they can bypass this check. Otherwise, interactively, we get them to type something which doesn't make sense. So just to break the thought, to say, all right, you're so focused on something, let's get you to think. Do you really want to do it? And here's our check. And the API implications for this is, for a library, you would need the implementers to be able to provide some ranges of values where these are expected usage, these are unusual, maybe warn but continue, and here are these are dangerous values, you should not use them. Right. So right now they're still in idea phase. Yeah. And things like if a task has been running for much longer than it normally does, maybe warn the user. Yeah. So that's also kind of hard to do unless you have some sort of expected range. And design for dry run. So show what the user, show what the software would do before actually doing it. So this is like so Git is good with this for like if you want to force push. Normally you go force push with -n, so that tell me what you're going to change if I force push, and if I see the expected state is I'm only changing this one branch, which I want to really hack the history on, then yes, I will take away the n and let it go through. Otherwise, if it's going to change multiple branches, that's not what I meant. So the user can actually have a chance to see what would happen and not do it. So that means, like for the task execution graph, run through all of them, try and figure out what's the state of the system, what am I going to change it to, and then present that as a report to the user without actually doing it, and then provide them the command, run this again without this, with this flag or without this flag, to actually do it. Yeah, so that's also idea phase, but super useful to user experience. Okay, so yeah, more ideas and to do. So to do dry run, to do make API ergonomic. So right now, all of that, all of those live demos, they are doable, but the API still allows the implementers to make mistakes. So I haven't gotten good types to let you only specify valid values or make it ergonomic to access shared state. More granular execution. So right now, it kind of borrows chunks of. Actually, it borrows the whole task graph, finds out what can be done, be executed right now, and when those things are run, when each thing finishes, maybe a next thing can be done already, but because the iterators are borrowing the whole task graph mutably, we cannot start something else until the current set of tasks that we could start before has finished. It's complicated, but yeah, I racked my brains on Saturday night. Got quite frustrated figuring out how that worked. Yeah, don't know how to make it work properly now though. Yeah, share data access, mention that, and handle signals. So right now there's no automatic management of signal handling. So if you Control-C the execution, it will stop rather than stop gracefully. So for example, if you have a task which is backing up the database, you Ctrl+C, you might say, all right, stop after you back up the database, but don't just stop like halfway through backing up the database, kind of thing. Yeah. So that's to do. Yeah, there's more ideas. So instead of using choochoo just for the end user, like running it on your computer, you could have it as an agent running on the web server, receiving requests, and doing all of this resiliently. So if the agent on the web server uses this library, it says, oh, I need to update this config, then it's already updated, then I don't have to do it, right? So it doesn't have to be interactive from the user's computer device. Right. Yeah, split kind of core functionality, we mentioned that. Serializing state to disk, so like save state of what happened during the execution. Usually after execution you've got a report, but what if you wanted to regenerate the report later on? Usually you can't do that because it's already printed there once, but you don't have the strong data types where it came from. So I find that kind of useful sometimes, but yeah, it's still an idea. Okay, so that's choochoo. So any questions? Oh yeah.
So the people writing this sort of deployment steps, is that going to be in Rust or in some kind of configuration language or DSL?
So there's this thing where if you have a compiler, you can have compiler support. So that means if choochoo expects certain types to be defined a certain way, if you write it in Rust, then you will know when you coded it wrong. Whereas if you have say a markup language like YAML, it's easy to get your spacing wrong, kind of thing, or it's hard to give a nice error message to the user to say, in this YAML file at this line, this column, you gave me this value, but that's the thing that caused me to fail later on. Most of the Rust crates for parsing certain formats don't give you that line and column or the byte position information. They parse it into the data type, but if it fails to parse, I mean, you get the line, you get the position information there, but if it succeeds parsing but is an invalid value, that's when you've lost that information. Got that? Yeah, and that's the information which is necessary to provide a good error message. So I have this debate in my head where if we wrote a grammar where, yes, you can write YAML, but you have a grammar which actually knows the structure of the YAML, where things should be, then you can store that position information alongside the actual parsed version of it. Yeah, but that's a lot of work. So yeah, it depends on whether there's enough people to build it. Yeah. Yeah, Tim.
Like your warning and error system, did you borrow that from NewShell or from?
So NewShell also backs onto CodeSpan reporting, which is the crate which formats it nicely. So just to bring it up. So he created. Actually, let's just go to CodeSpan. So the one that he created, I think, might have been with a few people, is called Annotate Snippets, which is the actual one which Rust, the Rust compiler is using. CodeSpan reporting is created by someone else called Brendan Zab. He has a different API, but very similar rendering, configurable as well. And so given, maybe make it bigger. So given some text and some labels like positions, so the file ID links to that text, and some messages, it will render your pretty thing. Yeah, output. Yeah, so if you look at the API here, your codes are strings, and then these messages are strings as well. Source error, which is my toy crate, was an attempt to make it strongly typed. So your error codes are strongly typed. You define the messages in as part of your error type, and so it's not just strings littered throughout your code, it's all collected in your error type. Yeah. Cool. And Mark. Sweet, I think that's us. If you want to know where the library lives, it lives on GitHub. So just GitHub/Azrael91 choochoo. And this book is called Ops UX, Operations User Experience. It probably can be titled better, but yeah, that lives on GitHub as well. Yeah, free to play. Cool, thanks.
From where it is behind me.